Okay, we are doing study guide 13.0b, which is adding and subtracting rational expressions. Now, when I say rational expressions, all I really mean is fractions. But the thing about these fractions is they contain monomials and polynomials. Monomial, 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 monomial. Polynomial, because it's two terms, it has that addition sign. Polynomial, two terms. Polynomial, polynomial. Binomial, polynomial. Polynomial, polynomial. See the difference? So let's start out with number 1. It's 8y over 10 plus 2y over 10. Now, first and foremost, what you have to know is that they have to have a common denominator. Well, lucky for us, these do. So our common denominator is going to be 10. So what we're going to do now is add our numerators. So I have 8y plus 2y. And when I add those together, because they are like terms, I'm going to get 10y over my common denominator of 10. Now here's the cool thing about monomials. Since there are no addition or subtraction signs here, this isn't a binomial, a trinomial, it's a monomial. Monomial I can just factor so easily by breaking this apart into factors. And the same thing in my denominator. 10 is also a monomial. So if I break apart 10, I get 2 times 5. So I've got 3 factors in the numerator, 2 factors in the denominator, and I'm going to cancel out common factors. So I'm going to cancel out my 2's, I'm going to cancel out my 5's, and I'm left with y. And if you want to get technical, these are all little 1's when you cancel these out, so it's y over 1, which just simplifies to y. So that was pretty easy. Look at number 2. 7x over 10 minus 2x over 10. Once again, I have a common denominator of 10. I don't have to mess with my denominators at all. But this time I'm subtracting my numerators. I have 7x minus 2x, and 7x minus 2x is 5x. Once again, these are monomials. I can just factor them so easily by breaking them apart. My 5's cancel out, and I'm left with x over 2. Easy. Number 3. 4x plus 3 over x plus 1 plus 3x plus 4 over x plus 1. Once again, I have a common denominator, so this is so simple. My common denominator is going to be x plus 1. Now, what are we being asked to do with the numerators? We're being asked to add them. Now, this time, the numerators are binomials. So I'm going to add this binomial to this binomial. And if you remember, when we added polynomials before, all we had to do was distribute a 1 here and a 1 here and do the distributive property. And nothing changed, because when you're multiplying by 1, the identity property says nothing changes its value. So 1 times 4x is 4x, 1 times 3 is 3, 1 times 3x is 3x, and 1 times 4 is 4. Now, I got rid of all my parentheses. Now I'm adding these. I'm going to combine like terms. When I combine 4x and 3x, I get 7x. When I combine 3 and 4, I get 7. And in my denominator, I get x plus 1. These are no longer monomials. I can't just break them apart as easily as I did these. I can't factor them this easily, but what I can do is follow my menu, and the first thing I look for when I'm factoring a polynomial, I look for a GCF. These terms both contain a factor of 7, so if I pull that out, I'm left with 7 times the quantity x plus 1 over x plus 1. Now here's the important thing to notice. 7 is a factor, and x plus 1 is a factor, because this is being multiplied by this, and factors are things we multiply together to get a product. X plus 1 is one factor. It's a binomial factor. Even though it doesn't have parentheses around it, that plus sign tells us it's a package deal. So, two factors in the numerator, one factor in the denominator. These factors are exactly alike. They cancel out. So I'm left with 7 over 1, which simplifies to 7. That's number 3. Number 4. (6m) over m minus 5 minus m plus 10 over m minus 5. Now, my denominators are the same. I'm going to go down below this one so we don't get confused here. My denominators are the same, so I'm going to keep my denominator m minus 5. So this is huge right here. What are we doing? We're subtracting. This is a mistake I see over and over again, so I want you to make sure you listen to this very carefully. We're going to take 6m, and what are we going to subtract from 6m? Are we going to subtract the m, or are we going to subtract the 10, or do we have to subtract them both? We have to subtract them both. So how am I going to make sure that both of these terms get subtracted? Because so many times I see students put negative m and then plus 10. We got to make sure that that negative gets distributed to both terms. So we're going to do negative 1 times m is negative 1m, and negative 1 times 10 is negative 10. That way we make sure that each of these terms gets subtracted. M gets subtracted, and 10 gets subtracted. Now we can combine like terms. We have 5m's and negative 10 over m minus 5. But if you'll notice, this is a polynomial, and I think we can do some factoring. It's a binomial. Polynomials can be factored using our menu. My first step is to find a greatest common factor, and it has a greatest common factor of 5 times m minus 2 over m minus 5. Now, m minus 2 is a factor and m minus 5 is a factor, but they're not the same, are they? So guess what? I can't do anything more to this. It's completely factored. None of its factors are exactly the same. So this answer is perfectly fine. And this answer was also perfectly fine. Don't get tricked here into thinking this is m minus 5, so you can cancel it out with this, because it's not. It's 5 times m minus 2. Number 5, 6x over 8t plus 4x over 8t. Common denominator. I'm going to add my numerators, and they're monomials. But now we have a binomial here. So I'm going to combine like terms. Please notice my variables are completely different, aren't they? So I can't cancel them out, but I can break apart 10x. It's a monomial, so I'm just going to break it apart like this. And I'm going to break apart this monomial like this. This is still 8t. This is still 10x. Cancel those out. That's it. I'm left with 5x over 4t. That's my final answer. And we're going to do one more on this video, number 6. 7x minus 5 over 3x plus 2 minus x minus 9 over 3x plus 2. Once again, you have a common denominator of 3x plus 2, which is nice, so we're just going to keep it. Be careful. We are subtracting our numerators. So we're going to take this and we're going to subtract not just the x, not just the -9, but every stinking term in the numerator is going to